Good morning, everybody. So today what I want you to do is take out this graphing trig functions 1, and I want you to practice graphing y equals sine x, y equals tan x, and then for the third one, y equals secant x. So go ahead and pause the video right now and go ahead and complete those graphs, okay? Remember, use that unit circle going around and use the angles 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then go ahead and graph these and use the analysis of like what quadrant is that and what's the sign of that trig ratio, okay? All right, so go ahead and do that. Pause the video and I'll be back and I'll show you the answers to these. So you should have graphed sine x, and it starts at 0, 0 and ends at 2 pi, and it has a max at pi over 2 and a min at 3 pi over 2, okay? So I should be seeing that, okay? And graph, when I give you a grid, go ahead and graph throughout the entire grid, okay? And then y equals tan x, at every odd pi over 2, you're gonna have a vertical asymptote, okay? And then you're gonna have zeros at every pi. So at 0 at pi, 2 pi, you're gonna have the zeros, okay? Or x-intercepts, okay? And why is it going up this way? Okay, so 0 to pi over 2, okay, that's in the first quadrant. That's where x and y are both positive. So when you do the ratio, it's going to be positive. So the graph would have to be above, okay? And anywhere it's below the x-axis, that means the x or the y in that quadrant is negative, okay? And if they're both negative, then that makes it become positive. For instance, pi over 2, pi to 3 pi over 2, both the x and the y are negative in here, okay? All right, so that makes it positive. That's why this part is above, okay? And this part's below because between pi over 2 and pi, x is negative, but y is positive, okay? All right, and then secant x is the graph. Let me slide it up a little bit more. Secant x is the reciprocal of cosine, okay? And so wherever x is 0, okay, which would be at pi over 2, at every pi over 2, 3 pi over 2, 5 pi over 2, that's where you're going to have vertical asymptotes, okay? Because x is 0 there, because the definition of this is your radius of your circle over the x coordinate of a point on the circle, right? Okay? And so that's your graph should have looked something like this, okay? Up U's and down U's, okay? All right? All right, and make any corrections, okay? Just fix it, okay? And then I want you to submit this, okay? So you're gonna have this, your notes, and then your homework assignment, okay? Or everything's homework now, right? Okay. All right, so go ahead and do that, and let's go to our notes, all right? Before we go to our notes, and this might be out of order in the packet, okay? Go to this page, which is transformative periodic function. So the front page is the graph of sine x and cosine x. And then if you flip it over, okay, you have this sheet, okay? So I wanna talk about this prior to the actual notes for this lesson, okay? All right, so go ahead and pull that out. Go ahead and pause the video and pull that out. Okay, so this is the graph of y equals sine of x, okay? And a few things, okay, it repeats every 2 pi, okay, so that's important. So if we go a distance horizontally of 2 pi, it's gonna repeat, okay? It goes as high as 1 and as low as -1, okay? And notice it's equally spaced above the x-axis and below the x-axis, okay? So there's a type of symmetry here, okay? Where it's not mirror images or anything like that, but there is a type of symmetry here. We're not gonna worry about the name of it. But it's equally spaced above and below, okay? And so we're going to talk about transforming this. So remember, transforming is what you first learned in Math 2, how to shift things left and right and up and down, okay? And so if we start shifting this up and down, okay, we can tell by this midline, which is right now is the x-axis, and it's the midline because it's right in between this max and the min, okay? So this is called the midline. Okay, so you're going to be able to tell if it's been shifted up if you see that it's not equally spaced above and below the x-axis, okay, and there's more above the x-axis, then you can tell it's got shifted up. Or if there's more of this below the x-axis, then it got shifted down. I'm going to show you a demo in just a minute, okay, of what I'm talking about a little bit better, okay, so you see like an animation of it, okay. Um, and then we can shift it left or right. So if we shift it left or right, this point right here, you're going to see move to the right or left. And you're going to see this max. And this is the one we're going to use. We're going to use this max, okay? And you're going to see it move left or right, okay? And then we can see a vertical stretch. And so if you have a vertical stretch, that's going to pull these maxes and mins away from the x-axis. So this point's going to get higher and this point's going to get lower, okay? And then we can also shrink this, okay? We can compress it horizontally, okay? So we can squish it. And then what happens is if the normal period it takes to repeat is 0 to 2 pi, well, we can make this go from 0 to pi and start repeating, okay? And that's how you get, okay, so AM and FM radio, they're radio waves, okay? And they're waves something like this. And what happens is for FM radio, they change the period on this, okay? So they shrink it or make it longer, and that's how they get the different FM radio stations. Now, AM radio stations, nobody listens to AM, right? Okay, but AM radio station, nobody even listens to the radio. What am I saying? Okay, but AM radio stations, what they do is they change it's called the amplitude. So they change the height of this, and so it's going to be a higher max or a lower min, and they change that, and that's how you get different AM radio stations, okay? AM stands for amplitude modulation, and FM stands for frequency modulation, okay? And we'll talk more about amplitude and frequency in just a little bit, okay? All right, so the next graph, I'm going to just slide it up, okay, is the graph of y equals cosine x, okay? And we're actually going to use this one the most, okay? And this is why. The max happens right on the y-axis right here, where x is 0, okay? So if that moves left or right, that's going to be easy to see. So we're going to model stuff to come up with a periodic function that looks like one that we have. What we're going to do is we're going to use cosine. You can use sine, but I think cosine's easier because all you have to do is locate this max. If it's right here, I can tell it got shifted to the right that many units, okay? This is still the midline, and it's equally above and below the x-axis. So this is the midline. It's called the midline. It's right in between the max and the min, okay? Equally spaced, I said that. Period, how long does it take to repeat? 0 to 2 pi. And we can transform this. So we can shift this up and down, left and right. And we can do all of that stuff, okay? All right, so I'm gonna go and I'm gonna show you an animation for this, okay? All right, so let me show you that. Okay, so what you're seeing right now is the graph of y equals cosine of x, okay? Because at angle 0, the cosine ratio would be 1, okay? All right, so I want to talk about what these do, okay? So we have this a right in front of the function. Now recall from last semester, okay? That's the vertical stretch or shrink, okay? When we look at this a right here, okay? So if I make that a bigger than 1, then we can see it vertically stretches it. So if I make it 2, then we vertically stretch it by a factor of 2, right? So the y coordinates went from 1 to 2, right? If we make it 3 or 4, let's go ahead and make it 4, okay? Then that's a vertical stretch of 4, right? And you can determine this, all right, by it's this length right here, okay? And what that is we can get the length of from the max to the min, that vertical distance, and half it, and that's going to give us how much it stretched by, okay? So this amount that we stretch, this a value, is always going to be half the distance between the max and the min, okay? It's going to be always half that distance. Okay, so, because right now that distance is 8, right? Okay, so I'm going to move it back to 1. Okay, that's one of the easier ones to figure out, okay? We're going to talk about this b in a minute, okay? C, if you remember, this c causes it to move left or right, okay? So if we make it go to the right, okay, let's say pi over 2, Actually, I'm going to make that pi over 2. So it's exact, okay? So it moved exactly pi over 2. And guess what happened? This looks like the sine curve, right? Yeah, because the cosine curve, if you shift it over to the right, pi over 2, it looks just like the sine curve, okay? And the max is now at pi over 2, okay? So I'm going to go back and switch this to a slider. I'm going to undo. Okay, so here, no, still slider. That's not what I want. Okay, technical difficulties right now. There we go. Okay, so I can slide this left and right. I'm going to make this go back to 1. A is 1. Okay, and so I can move this. This would move it to the right 2 units. Okay, it's hard to see 2 units because we're in radian mode down here on the x-axis. Okay, all right. Okay, so let's talk about D. Okay, so I've got C back to 0. Okay, so now it looks just like it's back to cosine. Okay, and now what does D do? Okay, so D causes it to move up. You see how it's moving up? The entire function is moving up. Okay, if D is positive, we're adding to the y's. Okay, all right, so if we make D be 3, we shifted it up 3. Well, how do we know that, okay? How can we figure that out, okay? And what I want to do is I want to graph y equals this D, okay? And you can see the green line, right? That's your midline, right? Okay, so we can tell, right? D is 3. We can tell that it got shifted up 3 units by finding this midline. Now, where's this midline? Well, I'm calling it a midline because it's midway between the max and the min, okay? It's the average of the max and the min. It's right in the middle, okay? It's right in the middle of the max and the min. So that's the average of the max and the min, okay? And we're going to go through all this and show you how to calculate all this, okay, in just a minute, because we're going to have to figure out all this A, B, C, and D, okay? All right? Okay, so now let's talk about B, okay? I'm going to delete this. I'm going to move my D back to being 0, so it's back to the regular basic cosine curve. Okay? Now, what happens to B? Now, recall, okay, this is inside the function, right? And it's working on the x's. It doesn't do what we think. So if I make B be 2, okay, and remember, okay, so if you look, it repeats every 2 pi right now, right? Okay, if you remember, this is the horizontal stretch and shrink, okay? So if I make B be 2, look what happens. Now, instead of having a wave from 0 to 2 pi, now the wave starts to repeat at pi. Now, why? We're taking the horizontal distances and we're not multiplying by 2, we're actually going to half them, okay? And remember, it's the reciprocal of this, okay? So what we did is that 2 pi, we took half of it. And what's half of 2 pi? Pi, okay? Now, what if I make this be 1/2? What if b is 1/2? Or 0.5, right? That'd be 1/2. There, okay? Now, what just happened? Now it got stretched horizontally, okay? And now instead of repeating at 2 pi, it's going to repeat at 4 pi. Okay, so from 0 to 4 pi, you see how the wave, there's one wave right in here. From 0 to 4 pi, you're only seeing one wave. Why? Okay, so 0.5 is 1/2. What's the reciprocal of 1/2? 2. Okay, the normal period is 2 pi. So when we take 2 pi and multiply by 2, we get 4 pi. And that's why this thing is repeating every 4 pi instead of the normal curve, which is every 2 pi. Okay, and then we have the C value. That's the shift left and right. Okay, so I'm going to move B back to being 1 so that we have the normal period. Okay, so see, I'm back to 1, right? So what's the reciprocal of 1? 1. Okay, so 1 times 2 pi is 2 pi. Okay, all right, so now how about the C? Okay, so if I make the C, okay, actually I think I already talked about C, huh? If I move it, it becomes, yeah, I can move it left or right. So we're gonna use cosine to model, and I'm gonna give you a graph like this. Okay, what the goal of today is, I'm gonna give you a graph, that's been moved around, and we're gonna be able to figure out what the A, B, C, and D values are that will allow us to transform the parent function cosine x into this new function. Okay, all right. That was a mouthful, okay? And I realize that. And I think it'll start to make more sense once we start doing problems, okay? It usually does, okay? This is all kind of abstract right now, okay? And we don't have anything really concrete down in writing yet, all right? So let's go ahead and go to the back page of that transforming periodic functions, and we'll look at that, okay? All right, so you're on this page now, okay? This distance right here is called the amplitude, okay? And that's our A value for our function. That's our vertical stretch, okay? So I'm going to draw a little arrow to this. This is our amplitude, which we call A, all right? And the way we get this distance right here, okay, we're going to take the maximum minus the minimum, which would give us this entire vertical distance, and we're going to half it, okay? So our A is going to be our max minus the min and divide by 2, okay? And that's going to be our vertical stretch, okay? Now, if this is the cosine curve, okay, that's been transformed, okay? It's been shifted up because you can tell the entire graph's above, right? So we don't have that equally spaced above and below the x-axis, okay? So how much did it get shifted up? This is our vertical shift. That's our D. That's the next thing I'm going to do, okay? So this D right here, okay, this vertical shift is our D value, okay? And it is how far we've shifted it up or down, and it's right in the middle of your max and your min. Well, to get the middle is the average of the two, okay? So what we're gonna do is we're gonna take our max, but we're gonna add our minimum, so max plus min, and we're gonna divide by 2. That would put us right in the middle between the max and the min. It's the average of the two, okay? All right. This phase shift right here, okay? I'm waiting for B because B is the hardest. Is we got to solve an equation actually to find B, okay? The phase shift is right here. That's our C, okay? And we find it by finding this maximum and looking at the x coordinate, okay? So our C value is going to be our x coordinate of our first maximum, okay? So this is going to equal the x coordinate of the first maximum. Okay, and it's not the y coordinate. The max and the min are y coordinates. Okay, it's the x coordinate because it got shifted, and that's how much it got shifted over, right? Because this max is usually right on the y-axis for cosine. Okay, and it's easy. A lot of times, it's really easy to see what the max is. Okay, all right. So then the next thing is the period. Okay, all right. So we know that this period, the new period, we can get, and it's what I explained before, is we use our B value to find it, right? Our period, and this is what you have to recall, is 1 over B times 2 pi. Okay, so whatever this new period is, and we can look at the graph and see, okay, from here to here is our period, right? That's how long it takes for the wave to repeat. Okay, that's going to go right here. And I know if I take 1 over this B value times 2 pi, it's going to have to give me that period. And so we're going to be able to figure out this B value by solving for it. Okay, all right. Okay, so let's go and let's do some problems, okay? All right, so for today, okay, which is the 29th of April, all right, what we want to do is we want to find the amplitude first. That's our A value, okay? To look at this X scale though, all right, we have to realize that, okay, if we look here, okay, that's 0 right there. And that's 1, 2, 3, 4, right? It takes 4 equal intervals to get to pi. That means our scaling is by pi over 4, okay? So the X scale on this is equal to pi over 4, okay? So that's going to help us figure some things out, okay? All right, to find the amplitude, that's how much vertical stretch has happened. And what we have to do is we have to take the max here, okay, and minus the min and divide by 2. So if we look at this, our maximum is at 5, right? So our A is going to equal 5 minus our minimum, and our Y scales by 1. Okay, I should have said that. So this minimum right here is at -1. So this is 5 minus -1. And what that is the distance. That's going to give us the distance between the max and the min. And our amplitude is always going to be half that, okay? So this would be 5 plus 1, right? Which would be 6 over 2, which is equal to 3. So in our formula, A cosine, we now know it's 3 times cosine, all right? Okay, so now let's go to and let's find our B value, okay? Okay, so what I know is this first max, okay, it's 3 lines over, right? But it's not, the scale isn't 1, right? It's pi over 4. So this is pi over 4, 2 pi over 4, 3 pi over 4. So the coordinates of this point are 3 pi over 4, comma, and 5, right? And then down here, this minimum is 1, so pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So this point right here is 5 pi over 4, comma, -1, right? And then what we need is another max or another min, the next max or the next min, in order to see how long it takes for this wave to repeat, okay? So I'm gonna go to this next maximum right here, okay? So we're at pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So the coordinates of this point right here would be 7 pi over 4, comma, 5, okay? And so this horizontal distance from here to here is how long it takes for the wave to repeat. So you can go from max to max or min to min, okay? So right here, this distance right here, from this min to this min is gonna be the same as this distance. So it doesn't matter, you just have to go max to max or min to min, okay? So that will tell us what the period is, okay? So for us, our period is 7 pi over 4 minus 3 pi over 4. So 7 pi over 4 minus 3 pi over 4. And that would give us 4 pi over 4, which is equal to pi. So this wave repeats every pi units, okay? So that's our new period. That's our period that we know, okay? So we know if we take our period, which is pi, that came from taking 1 over b and multiplying it by 2 pi. Okay, so what I can do is I can multiply both sides by b, and that would give me b times pi is equal to 2 pi, and then divide by pi, and I get b is equal to 2. Okay, so now I know the b value that's causing the vertical or horizontal stretch. Now, because this is 2, this is actually causing a horizontal shrink by a factor of the reciprocal of this, which is 1/2. Okay. All right, remember all that from before? Okay, so that's our B. Now let's go and let's find our C value. Okay, our C value is how far it got shifted to the right. It's called the phase shift, okay? And so this got, usually cosine, this max is right here on the y-axis, right? So it's been moved over a little bit, right? So this right here, that distance right there that it got moved over is our C value, okay? All right, so what are the coordinates of this point right here? Well, remember it was 1, 2, 3, it was 3 pi over 4, comma 5. Okay, so what is our phase shift? Well, it got shifted over 3 pi over 4. So that's our C. It's as simple as that. Okay, because that maximum, we can tell it got shifted over that far, okay? All right, let's go to our D. Okay, so you can tell that this graph got shifted up a little bit, right? Because if it didn't get shifted up, we'd have equal parts above the x-axis and below. Excuse me. But we have more above, right? More of the graph is above, okay, than below. We're just this little piece right here, right? All these little pieces. Okay, so we know it got shifted up, right? So I know my d value is going to be positive because it got moved up, right? But what is the d value? Well, it's right in the middle between the max and the min. That's how much it got shifted up, right? So that's the average of the two, okay? So we know from earlier that this point right here is 3 pi over 4, comma 5. And this point right here is, this minimum right here is 5 pi over 4, comma -1, right? So what's the average of this 5 and -1, right? So that's our d value. So we're going to take our d, and we're going to take 5, and we're going to add our minimum, which is -1, and we're going to divide by 2. So that'd be 5 plus -1, which is 4, divided by 2, and that would give you 2. So now we know our A, we know our B, we know our C, and we know our D. We can write a function that will model this perfectly, okay? So what our function is y equals, or you could write f of x, okay? And it's our A, right? And our A was 3 from the first page, cosine of our B, and our B was 2, times, and so we need the double parenthesis right here, x minus, and it'd be x minus, and our C value, right? Our phase shift to the right, which is 3 pi over 4, close the parenthesis, and then plus 2. Okay, and that's our function. Okay, that function, this function will produce this exact graph. Okay, all right, let's do that was working through it. Let's just do one full blown, okay, together again. All right, and then that'll be it for today. Okay, right off the get-go, on this, we want to find the trig function that models the graph, and we're going to use cosine. Okay, and what we first want to do is we want to figure out the scaling on this x-axis. A lot of times students have a tough time with that, okay? And I don't see that I'm going all the way to pi, right? But I know this is pi over 12. So the second line is pi over 12. This scale right here, that line right there would have to be half of this one. Now, if there's 2 of them in here, then I'd have to take pi over 12 and divide by 3, or multiply by 1/3. Okay, so my x scale on this is going to equal 1/2 times pi over 12. So that would give me pi over 24, okay? So let's just count by pi over 24, okay? So this would be pi over 24 right here. Then this one would be 2 pi over 24, but that reduces to pi over 12, right? Okay? And then this would be 3 pi over 24, and this would be 4 pi over 24, and 4 pi over 24 reduces to this pi over 6. So we have the scaling right, okay? All right, so I know that the coordinates right here, I look at my y-axis, and the scale is by 0.5, right? Okay, so I know the coordinates of this point right here, this minimum right here, is pi over 24, comma, negative 2.5. Okay, and then I know this one is pi over 6. You can write it in 24ths too. Okay, so this would be 1, 2, 3, 4 pi over 24. I'm going to tell you, you won't have to get a common denominator if you do them all in 24ths, okay? That's why I'm leaving it. So then this would be 5.5, okay? And then I'm going to go to this next one right here. This is the min, right? This is the second minimum. And this is pi over 24, 2 pi over 24, 3 pi over 24, 4 pi over 24, 5 pi over 24, 6 pi over 24, and 7 pi over 24. So this is 7 pi over 24, comma, negative 2.5 again, right? And you could go to this next one if you want to do that one too, okay? So this is 7, 8, 9, 10, this would be 10 pi over 24, comma 5.5. Hard to see the decimal right there on that first one, okay? All right, so let's go through. I'm going to do these in order. I'm going to go A, then find the B, then find the C, and then find the D, okay? So the first one is called our amplitude, okay? And that's our vertical stretch. It's our A, okay? So how do we get this vertical stretched, okay? Remember, it's half the distance between the max and the min. So to get the distance between the max and the min, I have to take 5.5 and minus negative 2.5 and divide by 2. Okay, so that'd be 5.5 plus 2.5, right? So that'd give me 8 over 2. So this 8 is the distance, is the vertical distance between this min and this max, okay? And we're going to take half of it, so that would be 4, okay? So that's how much it got stretched. If we shifted it all the way down, that would be how far the graph goes above the x-axis, okay? And also how far below. If we didn't do any shift up or down, this number would be how far the graph goes up and below the x-axis, okay? Okay, so let's next find our b value. But before that, we got to find our period. Okay, I'm going to do this a couple different ways, okay? I'm going to go from max to max because that's kind of how what I said to do in the directions, okay? So our period, it's going to repeat from max to max. It'll always repeat, or min to min, okay? So that's how I'm going to do it the two different ways, okay? So max to max, okay, we're going to take 10 pi over 24 minus 4 pi over 24 because that's the horizontal distance it takes to repeat. So 10 pi over 24 minus 4 pi over 24. That would give you 6 pi over 24, which is pi over 4. Now, we compared the two x coordinates to the maxes, right? You could do the minimums too, right? So if you did 7 pi over 24 minus pi over 24, you would get 6 pi over 24. You see how you get the same answer? So you can't go max to min, okay? Well, you could if you doubled it, okay? Because that's going to be half the period right here. If you go from a min to a max, that would be half a period, okay? If you doubled it, then you would get the full period, okay? So that's another way to get the period, okay? A third way, all right? So how do we get the b value? Okay, so I know that if I take 1 over b, all right, whatever 1 over b is, and multiply it by 2 pi, I wind up with this period of pi over 4, okay? So I'm going to multiply both sides. I'm going to multiply both sides by 4b. So 4b times 1 over b times 2 pi equals, and then 4b times pi over 4. Okay, so what happens here is my b's cancel, and I'm going to be left with 8 pi is equal to b pi. Okay, and then I'm going to divide both sides by pi, and I get 8 is equal to my b. So now I have b. All right. All right. So now, okay, there's no name for that b value. Okay, so that's why it's not labeled. I just said find the period, and then we're going to find the b. Maybe find the b. Okay, so now the phase shift. That's how much it's gotten translated left or right, okay? So usually for cosine, and we're going to use cosine because it's just easy to find the max, okay? This max is over here on the y-axis, right? So I can tell it's been moved over, and how far has it been moved over? This 4 pi over 24. So that's our c value, that's our phase shift. It's 4 pi over 24, which is really pi over 6, okay? And then we need to do the d value, right? That's the vertical shift. Okay, so that vertical shift, again, I can see it's been shifted up because more of the graph is above the x-axis than below. And normally, it's balanced, right? The same amount above and the same amount below, okay? So the vertical shift is right in the middle of the max and the min. Well, how do I find the middle of the max and the min? You have to find the average, okay? And that's your D, okay? So your D is 5.5 plus your minimum, which is negative 2.5, divided by 2, okay? Because there's two numbers we're adding, we're finding the average of them, right? Okay, and 5.5 minus 2.5 would be 3 over 2, okay? Or 1.5, okay? And if you look, you can see if you graph 1.5, then it looks like it's equally spaced, right? You have equal amounts above that line and below that line, okay? So that's one way to kind of visualize and look at it, okay? So we're ready to write our function now, okay? So our function would be y is equal to our a value, our vertical stretch, which we now know is the amplitude, which is 4, cosine of our b value, which is 8, and then open a parenthesis, and then x minus our phase shift, which is pi over 6. Then we need to close a parenthesis and close parenthesis. And then we need to shift it up, and this is the amount that we need to shift it up, so plus 1.5. Now, this could also be 3 over 2. If you wanted to write it as 3 over 2, that's fine. Okay, the 1.5 and 3 over 2 are exactly the same. Okay? And that's how you model with trig functions, okay? So today what I'm giving you is I'm giving you the graph, okay? And then from the graph, you have to come up with the equation of it, okay? Tomorrow, what I'm going to do is we're going to have tables of values. We're going to do the same thing, but the information presented to you is going to be from a table, not from a graph. Okay. All right. So that's it for today. The assignment. Let me pull up the assignment sheet and I'll go over that with you guys. Okay. Okay. So today is 429. And we already did graphing trig functions 1, or at least you should have, okay? And so I want you to submit that, okay? I want you to submit the worksheet GTF2, and then on top of that, I want you to also submit your notes, okay? Please don't mix them all together. Just do one at a time, okay? When you order your PDF pages in order, and I don't mind if you do the notes first and then the graphing trig functions, but don't do like 3 pages of notes and then mix them all up, okay? That's really difficult, okay? And it's not organized, all right? I mean, we got to be a little more sophisticated than that, okay? Don't mix them up, okay? All right, so do this assignment, okay? And I'll have it due on Friday, okay? Which is May 1st, all right? You guys have a great day. See you later.